Today's lesson is going to be on the last conic we're discussing this unit, and that's called the parabola. A parabola is the set of all points x and y in a plane that are equidistant from a fixed line, and this fixed line we call the directrix, and a fixed point not on the line, and this is called the focus. So unlike the ellipse and the hyperbolas, we will have one focus versus the pair that we've seen in the last two conics. The midpoint of the segment from the focus perpendicular to the directrix is the vertex of the parabola. The line that passes through the focus and the vertex is called the axis of symmetry. So we are going to learn how all these different parts contribute to graphing our parabola. Okay, so down here towards the middle of your page, you will notice that they give us an example of a parabola with a vertical axis. They only display the concave up parabola, but please know that you also have a concave down option. This is the same what's happening on the horizontal axis. Even though they're showing you one that points towards the right, there also exists the one that points to the left. Okay, now when they talk about the axis, they're specifically talking about the axis of symmetry. So in this figure, the axis of symmetry must intersect both the focus and the vertex. So where are these located on this picture? Well, the vertex is this dot right here, so I'm going to label it with a V, and this dot here is our focus. Therefore, this vertical axis, known as the axis of symmetry, is the line that intersects that focus and that vertex. Over here, our horizontal axis, which is the axis of symmetry here, intersects the vertex and the focus horizontally. You will notice that there is a line that's perpendicular to the axis of symmetry, and that's this directrix. I'm going to label it DIR. Okay, and because it is always perpendicular to the axis of symmetry, if the axis of symmetry is vertical, horizontal will be the directrix. If the axis of symmetry is horizontal, the directrix will be vertical. Last but not least, let's talk about the distance P. Now you will notice, and actually I'm going to zoom in to make it a point because the distance is so small in these images. Let's start here with the horizontal axis. So when I talk about my P distance, the distance P I'm talking about is the distance between the vertex to the focus and the vertex to the directrix. You will notice in this image that these two distances are equal to one another. That's what we're talking about up here when I mentioned the equidistant. Okay, we're talking about that P distance. Okay, so whatever this distance determines how far the directrix is going to be from the vertex. Same thing over here. Okay, when we're looking at the vertical axis, the distance from the vertex to the focus and the vertex to the directrix, this is called P distance. Okay, so you are going to have to determine that P distance, and we are going to eventually learn how to do that when we start our graphing. Notice as well, when it comes to the equation of standard forms, how it's different to that of parabolas and of hyperbolas and ellipses. Notice that you only have one squared term when it comes to parabolas. Okay, so I'm going to come over here and just make a note here. There's only one squared term. There's only one squared term. Now, the coefficient of the non-squared term that will help us to find our p-value, okay? This is used to find our p-value. Remember, that value is important to us because that helps us know how far away to draw our focus in our directrix when we're doing that, okay? And you will also know that our p-value will eventually help us know what direction our parabola will be pointing in, okay? Whether it be up, down, left, or right. Okay, so let us start here with, I would say let's start with problem number 1, but I'm going to kind of do what we did in class. And I'm going to start with problem number 2, okay? So let us go to problem number 2 for now. So let me shift this paper down. Okay, so problem 2 here, they're giving us y plus 2 all squared equals -3 times x minus 5. And we are going to need to identify whether this graph is going to be pointing upwards, or as far as vertically, sorry, or horizontally. Well, the first thing we need to make sure we do is learn our formulas, okay? Not necessarily memorizing it, but maybe just getting acquainted with the fact that the x squared term will yield a vertical axis of symmetry because of its x equal. So if you're more of a visual learner, go back to the front of your page and put upwards and downward images of parabolas, because it will help you remember that if I have an x squared term, it's going to be concave up or concave down. Y squared terms tells us that our parabolas would be horizontally facing to the left or to the right. So when we look at our first problem, example number 2, notice that our y is being squared. And because our y is being squared, we know it's going to be a horizontal facing parabola. So let's come over here and just tell ourselves, hey, I know it's going to be pointing left or right. I don't know at this point yet, but I'm going to go ahead and say that to myself, and I'm going to go ahead and erase the option of up and down in the orientation section, so that I just narrow down. Out of 4 choices, I'm left to 2 choices, which is a 50-50. Now, the first thing I want you guys to do is find the p-value. Now, since we know the p-value can be found using the coefficient of our non-squared term, okay? Our coefficient of our non-squared term in this case is -3, sorry. So 4p, which is what we got from the formula, has to equal our coefficient of our given formula. So I'm just taking 4p and I'm setting it equal to this coefficient here. When I solve for p by dividing 4 on both sides, I'm going to get a -0.75. So -0.75 is our p-value. And then to find our vertex, our hk, always find the x-coordinate first. And if I set x minus 5 equal to 0 and solve for x, I'm going to get a +5. And if I set y plus 2 equal to 0 and solve, I'm going to get a -2. So in essence, what you guys have been doing is just writing down the opposite of those values. So let's come over here and graph 5, -2, and put that dot. And I know it's going to be there where I draw my parabola. That will either be left or right. Well, we can see that our p-value is going to help us with orientation. Because our p-value is less than 0, meaning negative, that means that our parabola is going to be facing to the left. Okay, so I'm going to say it's pointing to the left. And so I have, and what I like to do is I like to give myself like an idea, a reminder that it's going to be pointing left to help me with my graphing. Now, the p-value, we said earlier today that, let's go back to our picture here, that was the distance between the vertex and the focus, okay? So that's going to help us calculate where the focus is. So if I'm here at my vertex and I know that my focus is negative 0.75 units away, and I know it has to go left, right? I'm going to go over to the left 0.75. It's going to be kind of annoying the way we draw this because the points are going to be rather close, okay? So I'm going to go over negative 0.75 to the left. Let me zoom in here a little bit. Okay. So you can see what I'm doing here. Okay. So here's my vertex. I'm going to put the V here for my vertex, and here is my focus. Now, I know for a fact as well that the distance from my vertex to my focus is my p-value, but also the distance of my vertex to the directrix. So I am going to come over here and draw my directrix 0.75 units to the right, and I'm going to use a ruler here to speed up the drawing of my dash line. And this is my directrix. Okay, there's the directrix. I'm going to put my arrows, and I'm going to label it DIR. So remind me that I just drew the directrix, okay? So my P distance, and I know, by the way, my focus had to go left as well because I know it's left facing and focus has to be trapped inside the parabola, okay? So let's come enter some values here. So I needed to enter the value of my focus, and I had gone to the left from my vertex. So the left of 5 negative 2.75 would land me at what value? Well, if you subtract 5 minus 0.75, you're going to end up at 4.25, comma, negative 2. Okay, so let's go look at that visually. Okay, 1, 2, 3, 4, and then I had to go a little bit more to the right, 0.25, and then I still went down negative 2. Okay, so you can either do 5 minus 0.75, okay, or just count 4, and I know I had to go a little bit further, which is 0.25. So that's where I got this, 4.25 negative 2. Let's see about the directrix. Well, the directrix is this vertical line right here. I was at 5, and I had to go 0.75 to the right, because I know the P distance has to be the same. Well, 5 plus a little bit more is 5.75, so I'm going to say x equals 5.75. And that is going to be this directrix. I also need to draw my axis of symmetry. My axis of symmetry, remember the definition? It says that it has to go through the focus and the vertex. So in this case, it's going to be horizontal. And that makes sense because we already said that our graph is horizontally facing, ideally to the left in this one. So there's my my axis of symmetry. Okay, so you'll notice that you will always start graphing 2 points, those two, then 2 lines, and then lastly you will end up drawing 2 more points to help with the width of this parabola. So let's come over here. So the axis of symmetry is a horizontal line, and this horizontal line is intersecting our y-axis at negative 2. This is my y-axis, and it's intersecting at negative 1, negative 2. So I'm going to come over here to my axis of symmetry, and I'm going to say y equals negative 2. One thing I do want to draw attention to you is that I want y'all to notice the connection that if you recall that axis of symmetry intersects the vertex and the focus, you will notice that your equation of your axis of symmetry will always be where your coordinates match. So these are both in the y value, aren't they not? So axis of symmetry is y equals negative 2. Your directrix is perpendicular to your axis of symmetry. So if this is a y equals equation, this has to be an x equals equation because they are perpendicular to one another. Okay, they form a 90-degree angle. All right, so how wide am I going to draw this parabola? Is it indeed going to be what I have there, or is it actually going to be a lot more narrow, or is it going to be really, really, really super wide? I have no idea. All I know is that I need a set of points to help me determine how wide this goes. I know that the points are going to be symmetrical, because if it was this high, then it's going to be this low. Okay, there's always symmetry. So how do I find that? Okay, so come over here and write with me. Okay, the width of parabolas are determined by finding 2p, or 2 times p, and count from focus. Okay, now what exactly does that mean? All right, so here's what I'm saying. You need to find what 2p equals to. All right, so in our case, I'm going to put an arrow here because I don't have any more space underneath that. My 2 times my p would equal 1.50, okay? Negative 1.50 to be exact, but right now I'm only concerned with distance measurement, so 1.5, okay? Now, let's just put 1.5 to keep it simpler, all right? 0.75 plus 0.75 is going to give me 1.5. Now, what you're going to do is you're going to go to the focus, and you're going to use that 2p distance to calculate and plot where your new 2 points are going to be to help you graph. So I'm going to zoom in here again to make it really clear. Let's make sure this is really focused. Okay, so I'm going to go here to my focus, okay, and my 2p distance was 1.5. So that's going to tell me I need a point above my focus and below my focus to be able to draw this left forming parabola. So go here, 2p was 1.5, so let's count 1.5. 1.5. So there's going to be my first dot. So I'm going to put it right here, and actually, funny enough, my first little sketch actually was right on target. Come here, go 1 and another 0.5 distance, so it's going to be around right here. Okay, so it shows me how wide it's going to be, so I'm going to get rid of all these little lines here I drew. These were my estimations. I knew they were going to point left, but I didn't know how wide, right? Okay, so now I'm going to connect my vertex to the 2 dots I just found, and I'm going to curve. Okay, so I'm going to curve here, and there's my parabola forming, and I'm going to curve this way. Okay, that's all you do. And so notice that this little distance right here, it's kind of very tight, is the 2 times the p that you found. That's your distance. And then the distance, this little distance right here, I definitely don't have space to do right inside there, but that little space on both sides, that's your p distance. Okay, I'm pointing at the wrong thing, but I don't have my glasses, so I hope you know that I mean from here to here and from here to here. Okay, I'll try and do that a little bit better. There we go. Alrighty, so let's practice doing this again. And if you want the coordinates of those points, you can write them down. I know I provided them in the answer key of your homework. Let's do the other problem we did in class, and that is example number 3. Okay, now example number 3, I actually had students do it by themselves, and then I kind of jumped in. So because of time, I'm going to have you pause the video, and I want you to find as much as you can. Ideally, find the p-value, the vertex, and the focus, okay? And then when you get to that point, go ahead and unpause the video. So go ahead and pause. Okay, so let's check your work. All right. First thing you do is determine the orientation. Since our graph is x squared, we know it's going to be pointing upwards or downwards. So I'm going to go down here to my orientation and tell myself left and right, not going to happen. Then I'm going to go to find my p-value. The 4 times the p has to equal the coefficient of the non-squared value. This is the squared value, this is non-squared. So I'm going to put my 12, and if I solve for p, 4 times what gives me 12? Well, p is equal to 3. And that 3, being that it is greater than 0, tells me that the graph is going to point, that's correct, it's going to point upwards. P greater than 0 is always positive. As a matter of fact, over here, I should tell you that if it's left, it's p less than 0. That's what we got from upstairs. Okay, so we've got our p. Our vertex is next. Our vertex, we need to get x first. That's over here. So that's a positive 2 and a positive 1. So set those equal to 0 and solve, or just flip the sign. And we're going to go ahead and take ourselves over to the graph. Let me zoom back out here. And let's go plot 2, 1. So let's go to 2, 1 and plot our vertex. Since we've determined it's going to be up, again, I'm going to make a little sketch for myself. You know, reminding myself, I know it's going up, and that's just to help me visualize, okay? I don't know if that's the answer, and me just automatically assuming this is the answer is incorrect, okay? That's just a visual. We need to find the focus. So why do I need this visual? Because I know my focus is trapped in here. So I know from my vertex I'm going to be going up. And it makes sense because it says up here anyway. But up how much? It's always going to be my p distance. So in this case I'm going up 1, 2, 3, and there's my focus. So let me label this as V for vertex, F for focus. So the other example, we went horizontal movement. Okay, the other example, we were supposed to move left, the p distance, right, which was negative 0.75, left, negative 0.75, see, left. Here, I'm going to go, what? Up. Up what? Up the 3. So up 3. Okay, now remember, if I go up 3, I need to find the other p distance to the directrix, so I reverse 1, 2, 3. And right here, 3 distance away, is my directrix. So I'm going to do that. Okay, so directrix. Okay. So again, remind yourself, this distance here is p distance. Okay, did I draw that? It's really trying to make that as clear as possible. Next time I make a video, I should wear my glasses. Okay, and again, this is also p distance. Now the other line is our axis of symmetry. Our axis of symmetry goes through the focus and the vertex. Okay, and I will label this AOS. Okay. So let's find, after finding those characteristics, let's point out where their locations are. So we've done the vertex. For the focus, we had to go up 3. So that affects my y movement here. So 2, 1 plus 3 is a 4. Or you can just count it out. 1, 2, 1, 2, 3, 4. My directrix is this horizontal line intersecting the y-axis at -2. So 0, 1, -2. So my directrix is y equals -2. Now if my directrix is y, I know this has to be x. And again, you can still use the fact that the axis of symmetry intersects vertex and focus. And what do we notice? We notice that they both share an x value of 2. So that's my axis of symmetry, x equals 2. So now we need to determine how wide this parabola is going to be drawn. So the width is 2 times p, and 2 times 3 would be 6. And I know that if I'm drawing it like this, I need to have something on this side and something on this side. So that means the 6 distance will be counting to the left. 2, 3, 4, 5, 6. That's 1 point on the graph. 1, 2, 3, 4, 5, 6. Another point on the graph. So my little determined width here is definitely really off. It was much wider. So I'm going to come from here and curve upward to meet my parabola, and I kind of missed that, and it's going to bother me, so I'm going to correct it one more time. Let's see if I can aim better. There you go. And then this side as well, come over, curve, because we know there's a symmetry, right? So whatever happens on one side of this parabola, if you folded it over this axis of symmetry, this will overlap with this. All points on this side of the parabola overlap with these on this side. So there's our parabola. We are done. One thing I wanted to point out that I have not said over and over again is that please notice that your parabola always points away from the directrix, okay? It points away. So here is this wall, you know, called the directrix, and so the parabola is pointing away from it. Here is the wall. It's pointing away from it on this side. You could point on this side as well, okay? But this one was left facing. On this one, it's pointing away upwards, but you can have drawn a parabola down here where it's facing downwards. But they always point away, okay? So keep that in mind. So I left the other 3 problems for students to practice on their own, okay? So problems 1 and 4, the answer key is online. Let us move down to example number 5, whereby you guys classify equations as a conic of a circle, parabola, ellipse, or hyperbola using these little features that I've given here on the side. Okay, and ultimately you'll notice that you will leave this be because there's a little bit of common sense behind it. Okay, so what does A and C stand for in these boxes? Well, the A is going to be, let's see if you can see what I'm writing, the coefficient of your x squared term. Okay. And the capital C is the coefficient of your y squared term. Okay, let's raise this up a little bit. So, what I need you to do is calculate, or determine, sorry, what A and C is, and then you'll end up calculating A times C if necessary. So let's find my A, and what is my C? Well, A is the coefficient of x squared, so if I go to my x squared term, the number in front of x squared here is a 1, and the number in front of my y squared term is going to be 4, which is the coefficient of y squared is C. Okay, and I look over here to my right and I see if my A and my C value, if those two coefficients are equal, then automatically my equation is classified as a circle, but that's not the case. So all the other 3 options, you actually need to calculate what A times C is. So we're going to do that. So A times C in this problem, 1 times 4, is going to be a 4. And then we have to say, is 4 equal to 0, greater than or 0, or less than 0? In this case, it's greater than 0. Therefore, the symbol means therefore, or as a result, we will go ahead and categorize this as an ellipse. Okay. So what I want you to do is try the next 3 on your own, determine what AC is, and then go from there and give me your conclusion. Okay, so pause the video now, do it, and then come back and check with me. Alright, well, welcome back. A is 1. Here's the 1 in front of your x squared. C is also a 1. And we notice that over here, our A is equal to C. Therefore, we can say, whoops, therefore we say that it is a circle. Okay. let's go to part C. Let's find A and let's find C. The coefficient of our x squared term, here's our x squared, the coefficient is -2. Notice I didn't go over here. I went to the x squared term. What's the coefficient for the y squared term? Here's y squared, so C is 4. It's definitely not equal, so let's multiply them, and we get an answer of -8, and we recognize that -8 is less than 0, therefore less than 0 hyperbola. And if you guys think about it, the hyperbola formulas are always subtracting. This is how I remember it. Less than 0 means negative numbers, and so yeah, so because they're negative numbers, I think of hyperbola, the standard equation subtracts. Okay, like an ellipse, here the numbers were positive, greater than 0, and our standard equation of an ellipse adds, so that's how I always remember it. So this is positive for adding ellipse, this is negative subtracting for hyperbola. And here, last but not least, A, well, the x squared term, there aren't any. So we're going to put a 0, okay? There's no x squared term, no x squared. Okay. So that's why A is equal to 0. The C, well, there is a C value, it's a 2. And so when I do go to multiply it, 0 times 2 is going to be 2. Oh my gosh. 0 times 2 is going to be a 0. Therefore, we have a parabola conic. And that makes sense. I can't spell. Parabola. We're going to have a parabola conic because of the missing squared term. And again, that makes sense because didn't I tell you guys when we first started here, when we were looking at the table, if I can find my paper, when we were first looking at the table, I told you one of the main differences between this equation in standard form for parabolas and that of your hyperbolas and your ellipses is that this one only had one squared term. So again, that's why when you look at this, if you notice that there is one squared term, you don't have to do all of this. If you know your definition of parabola, it's already going to be shown clearly to you. Okay? So again, if your x squared and y squared terms are identical, you know it's a circle. If the multiplication of those two terms ends up being positive, it's an ellipse. Or if you multiply them and they become negative, it's a hyperbola. And that's it, my dear. That was our lesson for parabolas. If you have any questions, you know how to find me. Thanks for watching.